Okay, let us find the eigenvalues and eigenvectors for the matrix, which is A here. Okay, so let us solve this. The character equation is equation A is that is A minus lambda I, which is equal to minus 5 minus lambda and 2 minus 2 minus lambda, right? So which is equal to 0. Okay, so we get this as minus 5 minus lambda, right? And minus 2 minus lambda minus 4, right? So let us simplify further. So after simplifying, you get this as lambda square plus 7 lambda plus 6 is equal to 0. Okay, so you will get the two roots, that is minus 1 and minus 6. Okay, these are the eigenvalues. Okay, let us find the corresponding eigenvectors. Okay, that is the characteristic vector corresponding to lambda, which is minus 1. Okay, shall we? Yeah. Okay, so the characteristic vector corresponding to lambda, which is minus 1, which is given by, that is a minus lambda, which will represent as a plus I. Okay, where you substitute lambda as minus 1, okay, into x, which is equal to 0. So this implies that is minus 4 okay, minus 4 and 2 and 2 minus 1, okay, and which is x1 x2, which is equal to 0. Now the usual method, like you'll get two equations, like 4x1 plus 2x2, which is equal to 0, and you get 2x1 minus x2, which is equal to 0. So on solving this, we get x1, which is 1, and x2 as 2, right? So you get as 1 and 2. This is with respect to x1 and x2. Okay, so these are the eigenvalues. Okay, so we are done with for a lambda which is minus 1. Let us look at lambda which is minus 6. We have other root, right? So let us find that. Let us find the characteristic vector. Vector corresponding to lambda, which is minus 6, okay, which is given by, that is this will be a minus, so this would be
Yes, sir.
Yeah, and this is equal to x1, x2, right? Which is equal to 0, 0, right? Okay, so you get
Yes.
two equations again. So x1 plus 2x2, right? And 2x1 plus
Plus
4x2, right?
X. Yes, sir.
Which is equal to 0. So we get x1 value which has minus 2 and x2 value which is 1. Okay,
Yes, sir.
so therefore the corresponding values would be minus 2 and minus 1. So these are the uh, eigen value. Okay,
Well,
yeah, right. Okay, okay. So we have been given x, y, z, the unknowns. We have to find corresponding to that. Okay, let us start.
yes,
Yeah. Now, for the given system, the coefficient with respect to the coefficient matrix and the augmented matrix are, let us first write down. Okay, so that is a, which is, yeah, 1 1 1, right? And 2 1 minus 1, and 1 minus 1
sir.
and 2,
Plus
right?
2.
Yeah,
Yes, sir.
so this a and b, okay, would be, that is 1 1 1 and 2 1 minus 1 and 1 minus 1 and 2. Okay, colon. Okay,
Yes,
so 4 1 and 2, right? Yeah,
yes, sir.
so now let us find that. Okay, a b. Now let us apply the rows and columns by applying it. So let us put r2 and r2 minus 2r1. Okay, and
Yes,
r3, this r3 minus r. Okay, let us apply that. Okay, so this will be, after applying it, so this will change to 1 1, and this is same, right? So for r2 it will be 0, right? And minus 1 minus 3, okay, and minus 7, right? And for r3 it will be 0 minus 2 1 and minus 2, right? So we have done as required for the row 2 and for the row 3, right? And let us again further do the operation on row 3 again, right? So let us not touch the row 2. Okay, so this would be again, so this would be same, right? 0 minus 1 and 3 minus 7, and this will be 0 0 7, yeah, and 12, right? So from this we note that the rank of A, which is the rank of the augmented matrix AB, is 3. Okay, that is the number of unknowns are 3. So therefore the given system is consistent and has a unique solution Okay. So that is it is 1 1 and 1. Okay.
Yes, sir.
And this is 0 minus 1 minus 3, right? And 0 0 7, right? And this would be corresponding
Yes, sir.
to x, y, and z, right? Which is equal to 4 minus 7 and 12, right? Yeah.
Yes, sir.
So on further, what will be putting that as x plus y plus z, which is equal to 4, and minus y minus 3z is minus 7, and minus 7z, which is equal to 12, right? So you get z as 12 by 7, and y, when you substitute that, right, you get 13 by 7, and the x value as 4 minus y minus z, which is equal to 3 by 7, right?
3. Yes, sir.
So we got the x, y, and z value, which constitutes the unique solution of the given system. Okay.
Yes, sir.
Yeah.